All right, this is Mr. Gilman. Today we're going to talk about direct variation. There's a few things you need to know about it before we get started. All right, the equation for direct variation is linear. It's in the form y equals ax. So it is actually it's a line. X is to the first power and it's in the numerator, so we know it's a line. This is read as y varies directly with x. Okay. Normally we had the form of an equation of y. Okay. Now it's going to say the variables y and x and y vary directly. Write an equation that relates x and y, then find y when x equals 12. The key word is they vary directly. So once again, I'm going to start with my base equation. Y equals ax. And so what I need to find is my a value to begin with. So I'm going to say, okay, 2 equals a times 1, or 2 equals a. So I know my equation could be y equals 2x. But that's not all they ask. They want to know what is y when x equals 12. So what I can do is I can just plug in 12 for x, and I'm getting that from right here. What is y when x equals 12? Y must equal 24. That is my solution, and this is my equation. Let's do another one of those. Okay. Similarly, I'm going to start with y equals ax. I need an equation that relates x and y directly, and also I need to find y when x is 12. So I'm going to start by finding my equation. I'm plugging in x and y into my direct variation equation. I'm going to say 5 equals negative 2a over negative 2 over negative 2. A must equal negative 5 halves. So my equation would be y equals negative 5 halves x. But I want to also know what is y when x equals 12. Y equals negative 5 halves times 12. I'm going to go ahead and put that over 1. Now when I multiply, I can cross cancel. I notice that 2 goes into both of those numbers. So when I multiply, I get negative 5 times 6 is negative 30. And that is my solution. I could put over 1, but really that's still negative 30. Okay, so y equals negative 30. Let's go on to the next problem. Once again, I need to first write an equation, and second find y when x equals 12. So I'm going to start with my direct variation equation, where a represents the constant of variation this time. And we're going to say, I'm going to substitute in my values and solve for a. So I know that my equation could equal negative 2/3 x. Y equals negative 2/3 x. That's the first half of my answer. Secondly, it says find y when x is 12. So let's find y when x is 12. I'm going to say that y is equal to negative 8. And I canceled there because I noticed that 3 and 12 both have 3 in common. So y must equal negative 8. Remember, when you multiply fractions, you multiply straight across. Once again, same idea. I want to write an equation that relates x and y directly. So I'm going to start with y equals ax. Plug in the values they give me. A must equal 2, so I'm going to say find x when y equals negative 4. It's going to be a little different this time. I'm going to write my equation. Should be an x there. I'm going to find x this time when y equals negative 4. Divide by 2. X must equal negative 2. Okay, so this one's a little different because this time we're finding x and substituting in for y. Okay. In all of these problems, you always start with the direct variation equation of y equals ax. Plug some stuff in. 5 equals negative 2a, divided by negative 2, a equals negative 5 halves. The first step is finding the equation. This time again, we're going to try to find x, so we need to plug in negative 4 for y. Now, a good rule of thumb is whenever you see a denominator or a fraction in an equation, you should multiply. I'm going to pick 2 to multiply because I know 2 will cancel all my fractions out. 2 times negative 4 is negative 8, and the 2's will cancel in this case, and it will be negative 5x. If I'm finding x, I'm going to divide, and I'm going to say x equals 8/5. That would be the solution when y equals negative 4. Okay. I just want to do a little exercise here, and I want to know whether each problem is direct variation or not. I'll put yes if it is a direct variation. I'll put no if it is not a direct variation. So let's start at the very beginning. Once again, you have to go through the point 0, 0, and it has to be in the form of y equals ax, has to be linear. Is this in the form of y equals ax? No, we know this is a line and the intercept will be at negative 1, therefore it will not go through 0, 0. This is not a direct variation equation. The second one, right off the bat, 2x plus y equals 0. They try to throw you off. We need to know, is it in the form y equals ax? So let's find out. We need to solve for y. So I'm going to subtract 2x from both sides. Y equals negative 2x. Is this in the form of y equals ax? I would say yes. This is a direct variation. Similarly, once again, in the next one, it doesn't say y equals. We need to make it say y equals. So let's solve for y by dividing both sides by 3. Y equals 4/3 x. Is that in the form y equals ax? Even though there's a fraction, the x is still in the numerator and a is still just a number, so yes, this would be a direct variation. This example is a classic example of direct variation. There's nothing back here. It looks like y equals ax. It will be a line, x is to the first power. We know, yes, this is a direct variation. This problem can be tricky because right away it looks like it might be direct variation. However, we haven't solved for y yet. So when we add that 1 over here, we notice that y equals 2x plus 1. We can't have this extra intercept going up there like that on a line. Okay, you can't have anything added to your x. It doesn't look like this anymore. So this would be no, not direct variation. Finally, let's just add 1 to both sides and solve for y. Right off the bat, even if I divide by 3, I notice that we're going to have a number back here. That automatically disqualifies it. We're going to say no, not direct variation.